Hi guys, in this video we're going to return to our analysis of the imaginary unit I, starting with just the fact that we know that I is actually equal to the square root of -1. Now I will say that I is actually the only number that I would leave it as I. We tend not to write it as what it means, which is the square root of -1. But the fact that we know that I equals the square root of -1 kind of in the past has led us to the conclusion that what if I square both sides of this initial equation here? It would mean that I squared is equal to -1. And so my hope in this video is to kind of build on this pattern that you see here with higher powers of I. That is to say that when you look at these over here on the right, I have like I to the 40th, I to the 105th, I to the 3rd, I to the 5th, I to the 4th. If we're going to be dealing with higher powers of I, then it's worth taking a moment to talk about how we simplify higher powers of I. So we're going to build a pattern here, and the next thing that I want to really determine is just what would I be able to conclude about I to the 3rd, knowing what I know about I to the 2nd and I to the 1st. So I'm going to show my work kind of over here on the side, so we don't clutter things, but I'm going to acknowledge that I cubed is kind of like saying, I squared times I to the 1st. And when we look at things this way, we know that I squared is a -1. We really get -1 times I. So what this does is it leads us to the conclusion that whenever we see an I cubed, we're actually allowed to replace it with just -I. Let's build this up another step here. What if I'm talking about I to the 4th? How could I really interpret this knowing what I know about these two basic building blocks? So again, show my work off on the side. I'm going to acknowledge that I to the 4th could be written as I squared times I squared. And so you might even already have concluded in your head that that's the same as -1 times -1, but anybody will tell you that -1 times -1 is 1. And so a really neat fact here is that I to the 4th is equal to 1. Now what I want you to do for me is I want you to put a box around these first four here, because it's going to be important that we keep these in our back pockets. But we are going to continue to build on our powers of I here. So let's try out I to the 5th, except for this time I don't have to be as sneaky about it. I'm not going to compose this with a bunch of i's to the 2nd power. I know that I to the 4th equals 1. Dudes, this means that I could write I to the 5th as I to the 4th times I, which every time I have an I to the 4th, I know is really just 1. So I get 1 times I, and anything times 1 is itself. And so I should expect the moment I write this as I to the 4th times I, that this I to the 4th is really just a 1 anyways, and so what we get stuck with is just the I part. So fun fact, not only is I equal to I, but I to the 5th is equal to I. We're going to keep extending this pattern, because I do need you to see the pattern here. What if I have I to the 6th? Well, that would be the same as I to the 4th times I squared. And we know that I to the 4th is really the same thing as 1. And that I squared is -1. So we get -1. Let's keep running with this. I to the 7th would be the same thing as, let's see, I to the 7th would be the same thing as I to the 4th times I to the 3rd. Using what we've already known from up here, I to the 4th is just 1. And so we really can just neglect that. Anything in a product with 1 is itself. So we're really just going to get I cubed. But I cubed at the same time is -I. It is this thing right here. So I to the 7th is the same as -I. And then I to the 8th, I think we can start to wrap it up after this one. I to the 8th is I to the 4th times I to the 4th, which is the same as 1 times 1. Or in other words, 1. So what I want you to see is, if I were to go to I to the 9th, I say, well, what would I expect to get? What I can tell you at that point is anything like I to the 9th, I can tell you that how many groups of 4 can I make with 9 things? Every time I make a group of I to the 4th, I get a 1, and then I'm just keeping the leftover. So if I to the 9th, if I can make 2 groups of 4 i's there, I'm going to tend to write it this way. I could say this is I to the 4th twice. In other words, this is 8 total i's that you see right here, and I would have a single I left over off on the side. And so it's kind of an acknowledgement that all of these groups of I to the 4th are really just 1 to some power, which is really just 1. In other words, we're really kind of just looking for what we get left with over here. And so I'm going to get I again. So you're going to see this pattern happen. You say I is I squared is -1, I cubed is -I to the 4th is 1, and then it rolls back around again. I to the 5th is I to the 6th is -1, I to the 7th is I to the 8th is 1. And so it starts up again. I to the 9th is I to the 10th is -1, I to the 11th is -I, and I to the 12th would be 1. So when it comes to simplifying higher powers of I want you to know that we always want to keep these in our back pocket right here because we're always going to use these top four. And anything higher than that, okay, like I to the ninth, we're going to tend to write in groups of i's to the fourth because we're really grouping them up into 1 to some power whenever we can write an I to the fourth. So looking at simplifying some expressions here, I just think that they're kind of ugly the way I had them written here. I'm going to rewrite this. But if I said let's go simplify this, well, let's take what we know about I cubed and I squared. In this case, we just learned that I cubed is the same thing as just a negative I. And so I get a negative I here. We can replace I squared, right, with a negative 1. And so when we write this out, we get negative 6 times negative I, which is 6I. And this would be minus 1. And if we want to write this as a complex number in standard form, we would have to write the real part first and the imaginary part next. And so you can see that because I to the third and I to the second can be re-expressed as negative I and negative 1 respectively, we were able to take something that wasn't in standard form and rewrite it in this A plus BI standard form. And as a matter of fact, any higher power of I, you're going to see either becomes I, negative 1, negative I, or 1. And so all these higher powers of I really just kind of collapse down to either I's or 1's of a negative or a positive flavor. So when we look at something like this, consider negative 14 I to the fifth. Now I to the fifth, that's bigger than I to the fourth. So whenever we end up with an exponent higher than I to the fourth, what we're going to do is we're going to split this up into groups of I to the fourth. So if you think about 5, how many groups of 4 could you make? If you had 5 of something, we could make one group of 4. So you're going to see me write this as I to the fourth to the first. And in other words, what we're saying is the number of groups of i's to the fourth. So I had one group of I to the fourth. If I had 5 total i's and I put one group of 4 together, I would have a single I left over on the right-hand side of this. So we have negative 14 times I to the fourth one time times I. This is our initial expression. But what do we know about I to the fourth? Well, it's 1. So what this truly means is we really can just ignore this at this point and say that what I get left with is negative 14 times the I to the fourth, which was 1, times an I. So negative 14I to the fifth is the same thing as negative 14I in value. So let's keep looking at a couple more here. Letter C. This is a little bit different. We've got, if you're looking at this critically, 3I to the fourth power. This means that I have to take 3 to the fourth, I to the fourth, or in other words, I get 81I to the fourth. The thing is, we wouldn't want this higher power of I. And so when we look at what do we know about I to the fourth, we know that I to the fourth is 1. And so in other words, we just get the 81. Okay, now this is our final expression, and this is going to take some simplifying, but we have I to the 40th plus I to the 31st minus I to the 14th plus I to the 105. The thing I want you to keep in mind is that for every group of I to the fourth that we can make here, right here, try to go back up here, that really comes out to be a factor of 1. And so what we're trying to do essentially is make as many groups of 4 i's as we possibly can. So now, I did start with I to the 40th for a reason, because we probably wouldn't need a calculator to tell us how many even groups of 4 could you make if you had 40 i's. So last time I checked, I could make 10 groups of I to the fourth if I needed I to the 40th. So the way we're going to write this is, this first term would be I to the fourth, but we can make 10 groups of this, and I wouldn't have any i's left over. So this is really representing our first term here in this sum. So now when we look at I to the 31st, what I would tell you is we're just going to take 31 and we're going to divide it by 4, because what we want to acknowledge is at least I can make 7 groups. I may not be able to make 8, but I can make 7 groups of 4 i's. So we're going to write this as I to the 4th, to the 7th. And when you count these up, remember multiplying your exponents here, this is 28 total i's right here. And so when you look at the fact that we had 31 to begin with, when you take the total of 31 and say I'm representing 28 of them right here, it means that there were 3 i's left over on that term. So here's our 28 i's in groups of 4, and then we have times an extra 3 i's to make this 31 i's. So now, I want you to think about this. If we had 14 i's, how many groups of 4 could we make? 3. And so we're going to look at it this way. I to the 4th, 3 groups of that. And if I had 3 groups of I to the 4th, that'd be 12 total i's. Well, there were 14 here to begin with. So that means that there was an I squared, or 2 i's left off on the side that we couldn't group into whole groups of 4. So now we've got this term, this term. Let's go with our last term here. And this is where we will need a calculator. I don't know. I mean, I get 105 divided by 4. It means that we can make 26 whole groups of I to the 4th. So we're going to write I to the 4th 26 times. 26 times 4. That means that 104 of our i's, they're sitting right here. And so if we had 105 to begin with, that means that the extra I to the 1st has to be here. Now, the reason why we grouped these into i's to the 4th in the first place was just because we know that every time we have an I to the 4th, we really mean 1. So this becomes 1 to the 10th plus 1 to the 7th I cubed minus 1 to the 3rd I squared plus 1 to the 26th times I. I would not normally write it out as I've done, but I do want to show you how I do arrive at my conclusions. And so when you look at 1 to any power, what you really get is 1. And so that is to say that up here in this original expression, we can really just look at the thing of substance as being what was either in front of this or what it was attached to on the right, because all of these i's to the 4th really just mean 1. So here we get 1 to the 10th, 1. Here we get 1 to the 7th, which is 1, but times I cubed. So really plus just the I cubed part, minus, this is going to be 1 to the 3rd times I squared, or in other words 1 times I squared, so minus I squared. And then this will be plus I. So from here, all we need to do is rip down our powers of I even further. I know that 1 is 1, but I cubed is the same thing as negative I minus, now I squared, we can substitute in a negative 1, and I is just I. So simplifying this, we get 1 minus I plus a positive 1 plus an I. And as we combine like terms now, starting with your real parts, we get 1 plus 1 is 2. And negative I plus a positive I, these actually cancel this time. So I'm going to say, because I want my answer as a complex number in standard form, that we get 2 plus 0I would mean the same thing as this complex expression with higher powers of I. So just remember that when we're reducing powers of I, you're going to try to make them or split them up into as many groups of 4 i's as possible, because I to the 4th is 1. And then we're going to be looking for the substance that was really left over on the side here to kind of try to simplify it further. Cheers.